are you? Today, revision on Unit 1. What is the meaning of energy? Energy is ability to do work, like food. When we don't eat the food for a long time, we can't do anything. Why? Because the food gives the body energy. Let's remember forms of energy: magnetic, light, sound, heat, electric. Light energy is the only form of energy that can be seen. What is the meaning of the visible spectrum? It is the light energy that can be seen. What are sources of light? Sun, candle, electric lamp, stars. Properties of light. Light travels in a straight line, transmitting light through different materials. Light reflection, light refraction, light separation. From traveling of light in a straight line, number 1, formation of image through the narrow hole. Number 2, formation of shadow.
Formation of images through narrow holes or pinholes. The idea of photographic camera is based on the idea of formation of images through narrow holes due to traveling of light in straight lines. This activity to prove that formation of images through narrow holes or pinholes is due to traveling of light in straight lines. Steps: remove one side of a carton box and replace it with a piece of a semi-transparent paper. Make a small hole in the opposite side of the semi-transparent paper. Darken the room, then put a lighted candle in front of the hole at a certain distance and look at the semi-transparent paper. Move the candle forward or backward until you see a clear picture of the candle flame on the semi-transparent paper. Observation: a minimized and inverted image of the candle flame is formed on the semi-transparent paper. Conclusion: formation of images through narrow holes or pinholes is due to traveling of light in straight lines.
What kind of an object is a human body? Are we able to see through it? Not really. Hence, a human body is an opaque object. What happens when light is obstructed by the human body? We see that the human body is obstructing light here. There is light in front of the human body, but what do you see behind it? Yes, a shadow. This thing you see behind the body is called a shadow. Now, looking at this, can you tell me the things that are required for a shadow to be formed? Two things are obvious. First, a source of light, which is in front of the body. And second, an opaque object. Here, the human body is the opaque object. Can you identify any other thing we may need for a shadow? Maybe not. Now let's consider a different situation. In this situation too, we have a source of light as well as an opaque body. But do we see a shadow? No, we don't. Do you know why? Perplexed? Well, had there been a screen behind the opaque object, you would have seen the shadow on it. But because there is no screen or surface like in the previous case, we cannot see the shadow. What does this tell us? It tells us that we also need a surface on which a shadow can be formed. That surface will make us see the shadow. What's so special about shadows? Shadows also give us some information about the object. So if I show you this shadow, you will be able to tell me that it's a human body shadow. But sometimes they can also be misleading. For instance, can you name the body of which this is a shadow? You'd probably say it's that of a dog, but it's just our human hands playing the trick. Has it ever occurred to you as to why shadows are formed? We know one of the reasons. Opaque bodies do not allow light to pass through them. Yes, that's one of the main reasons why shadows are formed. Another important reason for shadows to form is that light travels in a straight line.
There are differences between transparent, translucent, opaque. Remember, translucent equals semi-transparent. What is the meaning of transparent? They allow most light to pass through. Object can be seen clearly. Example, air. Translucent, they allow some light to pass through. Objects can be seen less clearly. Example, tissue paper. Opaque. They don't allow light to pass through it. Object can't be seen. Example, rock. Now with the video.
You need light to see the objects. And what we will learn in this session is the concept of light. Now let's slowly lighten this room. Why are we now able to see the objects in the room? The reason is that now light reaches us from these objects. Light from the source falls on the objects and travels to our eye. Light helps us see objects. Do you know what the source of light is called? Objects like the sun or the tube light or the torch are called luminous objects. Can we now see the objects outside the window? Nope, we can't. But the question is why? It's easy. Because the light from the outside of the window does not reach us. The wooden shutter blocks this incoming light. Such objects are called opaque objects and they are very large in number. Almost everything around us is opaque if you think about it. Wood, metal, sheets, colored plastic and so on. Now let's open the wooden shutters. Can you see something new? Yes, we see the surroundings through the glass. And I'm sure you know why. What has happened now is that we have a clear glass which allows light to pass through it, allowing us to see through it clearly. Such objects are called transparent objects. Earlier the wooden shutter was opaque and the opaque objects do not allow light to pass through them. Now look at this shelf which has a milky glass. Are we able to see what's inside? Well, we can't see the things clearly, but you do see something, right? You can probably guess that books are kept inside. Yes, milky glass allows light to pass through it, but only partially, and one can see some light coming through it. What is the difference between the two? While the objects like clear glass are called transparent objects, the objects which allow light to pass through it partially are called as translucent. We can easily think of examples of opaque objects. But can you think of other transparent or translucent objects? Yes, clean water, glass, clear plastic bottles and air are all examples of transparent objects. Can you think of examples of translucent objects? Yes, butter, paper, thin sheet of plastic, milky glass are a few examples of translucent objects.
Now we know what is the difference between light reflection and light refraction. Light reflection, it is returning back of light rays when the light falls on a reflecting surface. Light refraction, it is a change in direction of light rays when light passes through the separating surface between two different transparent media. Why? Due to the change in light speed. Light speed in the air is faster than the light speed in the water.
How do we see things around us? You will probably say it's the eyes that help us to see the objects around us. But will our eyes be able to see these objects in dark? No, we need light to see things. Without light, we cannot see the objects. But where is this light coming from? This light is coming from this source, which is a fluorescent bulb. You see that this bulb is emitting its own light. The objects which emit their own light are called luminous objects. Can you give me any other examples? Incandescent light bulb, the sun, the stars are also luminous objects. What about objects such as this table and chair? Do they emit their own light? No, these objects do not emit their own light. Such objects are called non-luminous. Almost everything around us is non-luminous. Objects made up of wood, plastic, cotton, metal are all non-luminous. What about the moon and the planets? They are also non-luminous. But if the moon is non-luminous, then how come we're able to see it at night? The answer to this is reflection of light. The reason we're able to see any non-luminous objects around us is because of the reflection of light. Reflection of light can simply be referred to as change in direction of light or bouncing of light from some surface. Just like the ball bounces from the ground, light reflects off from a smooth surface. Let me try to explain this in a simple way. The light from the source strikes the object and bounces off from its surface. And when this light reaches our eyes, we see that object. And this is how we see non-luminous objects. When the object is kept in front of the mirror, its image is formed in it. But will we be able to see the image in the dark? No, we won't. So the formation of the image is also due to reflection of light. Let this object be our human body, so at the same time we are looking at the image. First tell me, is our body a luminous or a non-luminous object? Well, it's non-luminous. Human body cannot emit its own light. So the light from the source is first incident on the human body. It gets reflected from it, and this reflected light strikes the mirror. This light is further reflected from the surface of the mirror and reaches our eyes. This is how we are able to see our image. Now obviously, this is not the exact picture of the happenings. I just wanted to give you the intuitive feeling into how this happens. There are a lot of subtleties involved which we will learn in our higher grade.
Topic: refraction of light.
Huh?
Why does a pencil look bent in water? Wow, that was a very cool magic trick. Now check this out.
Oh.
Hey, stop crying. Your magic wand is not bent or broken. Look, it is safe. But do you know why your magic wand appeared bent in water?
Huh? Oh.
It is because of refraction of light. Refraction of light is the change in direction of light when it passes from one medium to another obliquely. So, what do you think are the two media here? You don't know? No worries. I will tell you. They are air and water.
Oh.
When the light rays coming from the tip of the magic wand pass from water to air, they change their direction, that is, they get refracted. When these refracted rays reach our eyes trace them backward as straight lines. Due to this, the rays appear to come from a point slightly above the original position. Hence, the magic wand appears to be bent in water.
Oh.
Similarly, like the magic wand, a pencil appears to be bent in water.
Light separation. We can separate the white light into 7 spectrum color by using a prism. Why? As the white light consists of 7 spectrum color. Remember with me. Spectrum color: red, orange, yellow, green, blue, indigo, violet. When we mix 7 spectrum color, is produced white light again.
Colors in white light. Significance of white color. Colors in white light. Significance of white color. You have studied how rainbows are formed and what are its constituent colors. Now, we can say that the sunlight is a mixture of different colors. Let's do an activity to understand it. Take a glass prism and place it on a table. Allow a narrow beam of sunlight through a small hole in window of a dark room to fall on one face of the prism. The light bends when it passes through the prism. Now, let the light coming out from the other face of the prism fall on a white sheet of paper or on a white wall. You can see that different component colors of white light bend by different amount, and so the constituent colors can be seen separately. Do you see colors similar to those in a rainbow? This shows that the sunlight consists of 7 colors.
Now the question arises that can we mix these colors to get white light again? Let's do another activity to understand it. Take a circular cardboard disc of about 10 centimeters diameter. Divide this disc into 7 segments. Paint the 7 rainbow colors on these segments as shown here. Pierce a small hole at the center of the disc. Pass the tip of the refill through the center of the disc. Rotate the disc in the daylight. When the disc is rotated fast, the colors get mixed together and the disc appears almost white. Such a disc is known as Newton's disc. Now you know that it is possible to get white light after mixing 7 colors.
Seeing colored object. We have two types of colored object. Seeing the colored object, transparent and translucent. Number 2, seeing the colored opaque object. Seeing the colored transparent and translucent object, we have question. Why we see the bottle is green? As the bottle is absorb all color except the green, allow to pass through it. Number 2, seeing the colored opaque object, we have 3. White, black, colored opaque object. Why we see the t-shirt is white? As the white reflect all color. Why we see the t-shirt is black? As it absorb all color. Why we see the t-shirt is red? As the t-shirt absorb all color and reflect the own color red.
Look around you. Everything you see has a color. Different shades, different tones, like those of your classroom, your uniform or your pencil. All these colors help you see opaque objects. Opaque means anything you can't see through, like your hand or the walls of your classroom. Go on, can you look through them? No, they are opaque. But why does an object appear to be of a certain color? Why is an apple red and not blue, or the grass green and not pink? Let's take a closer look. Light from the sun or even a bulb consists of a whole spectrum of colors. Red, orange, yellow, green, blue, indigo, and violet. When light hits an object, each color hits that object, but only the actual colors of the object are reflected. The rest are absorbed. The colors that get reflected are the colors of that object. So, we can say the color of an opaque object depends on the color or colors of the light it reflects. For example, look at this. What color do you see? Orange. That's right. What's happening to the other colors? They're being absorbed. Now, what do you suppose happens if all the colors were reflected? What would we see then? White. The color white appears when all colors of the spectrum are reflected. But what would happen if all these colors were absorbed? What would we get if nothing was reflected? Black. Black is the absence of light and color. Things that appear black to us appear so because they absorb everything. Let's summarize what we have learned today. The color or colors of an object is the color or colors of the light it reflects. We see white when all the colors of the spectrum are reflected. We see black when all the colors of the spectrum are absorbed.
Seeing colored opaque object through colored transparent object. The opaque object is seen in its real color when you look at it through a transparent object that has the same color. In picture number 1, the apple appears red through the red transparent glass sheet. Why? Apple absorb all color and reflect the red color. It allows to pass through the red glass sheet. Picture number 2. The apple appears in new color through the green transparent glass sheet. Why? The apple absorbs all color and reflects the red color, but it absorbs opaque green transparent glass sheet and it doesn't transmit through them. Mixing the colored lights. We know the difference between primary colored light and secondary colored light. Primary colored light example: red, green, blue. What is the meaning of primary colored light? They are colored light which cannot be produced by mixing two other colored lights. When we mix red, green, blue, it produces white light. But when we mix green and red, it produces yellow. When we mix green and blue, it produces cyan. When we mix red and blue, it produces magenta. So, yellow, magenta, and cyan are secondary colored lights. So, what is the meaning of secondary colored lights? They are colored lights that are produced by mixing two of the primary colored lights.
Perception of color is a very subtle thing. When Newton first took white light and spread it out with a prism to show a rainbow of colors, what he arrayed in that spectrum was a position for every different wavelength, for every different color, every frequency of light. But the way that we perceive it is something different. What we perceive as human beings is according to the receptors that we have in our eyes, which see red, green, and blue. So even though it may be a whole spectrum there, we'll interpret it in terms of how much red, how much green, and how much blue there is there. And that's much the same way as how a camera works, which is why video cameras work for human beings, because they also will record red, blue, and green, basically to match the perception that we have. So you can have a full color spectrum, but whether it's a human being or a camera that's detecting it, what it will see is a proportion of red, blue, and green. Well, just as we can look at a white light spectrum and see all the colors in it, even though we only detect red, green, and blue with our eyes, we can take those colors, red, green, and blue, and put them together in different ways to make all kinds of different colors. So here what I have is 3 slide projectors that project the 3 colors. The blue is fairly pure color, the red one is fairly pure as well, and fairly pure green over here. But as they overlap, you see that blue plus green together gives you a different color, the cyan color that's here. Red plus green together give the yellow color down below. And red plus blue together give the magenta color that you see at the left. But all 3 of those colors, as they overlap, give a white spot in the center. Now, if we subtract one of those colors, if we take out, for instance, the red, then that white spot turns cyan. If instead we subtract the blue, that white spot turns yellow. If we subtract the green, that white spot turns magenta. And so there are 3 colors that in a certain sense are white light, subtract certain colors. And there are these other primaries, the cyan, magenta, and yellow, that are the colors that are used in inkjet printers.
Exercise. Give reason. Number 1. You can see your image in a plain mirror. Answer. Due to the regular reflection of light. Number 2. White light can be separated. Answer. As it consists of 7 spectrum colors. What happens when, number 1, you look at a green apple through a red glass sheet? Answer. The apple seems black. Number 2, you place a transparent object between a light source and screen. Answer. No shadow is formed. Answer by yourself. Read question and answer. Give reason. Number 1. The rainbow appears in sky during rainfall. Number 2. You must wear white clothes in summer season. What happens when? Number 1. You look at an object through a transparent material. Number 2. Mixing red light with blue light. Thank you for listening and goodbye.